Good evening, students. Welcome to online class on PPS, Programming for Problem Solving. Yeah, in yesterday's class, we have seen few concepts related to functions, and yeah, this is what we have in your fourth unit: functions and dynamic memory allocation. And from this, we covered all these concepts, and whatever I marked with red color, we are about to complete. And in today's session, hopefully, we see the recursion. Okay, this entire thing, whatever I have marked with multiple colors like yellow and red, this whole thing we try to cover in today's session. So we see what is recursion, and we'll also discuss some simple example programs on recursion, such as finding the factorial of a given number and finding the Fibonacci series, and the GCD problem also we will try to discuss, and the limitations of recursions. Okay, so when we go for recursive functions, what are our issues, what are our limitations, that also we need to discuss. So with these concepts, we'll conclude today's session, and hopefully the remaining stuff like some standard C functions and libraries, the dynamic memory allocation, we'll try to see in our further classes. So with this, we can wind up the complete fourth unit. Okay, so hardly one or two more classes if we exclude today's session. In today's session, anyhow, we will discuss the recursion stuff. Apart from this, hardly I need one more session or two before we complete your fourth unit. Okay, so this C standard library functions we need to discuss, and dynamic memory allocation we need to discuss from your fourth unit after today's class. Okay, so without much ado, let's just go to this recursion thing. Yeah, this is a recursion. Okay, what is this recursion? First, we need to understand, and what is the importance of it in our C programming, we need to know. Okay, see, when we use this recursion, in the sense, generally, whenever we have to go for repetitive algorithm, so repetition in the sense executing the same statements more than one time. Okay, that is what we call it as repetition in our programming, and we know we use loops to achieve a repetition in our programming. So whenever you have the repetitive algorithm, so same statement, same set of statements to execute more than once, okay, repeated number of times, we use this recursion. Okay, so there are basically two approaches to achieve repetition in our programming. We have two different approaches to achieve repetition. One is using loops and the other one is using recursion. So we can call this recursion as an alternative approach to achieve repetition. Okay, so this particular thing, repetitive algorithms or repetition to achieve in our programming, we have these two approaches. One is loops and the second one is a recursion. Okay, so yeah, a recursion, it is a repetitive process where same set of statements will be executed multiple number of times like loops. Okay, recursion, it is a repetitive process. uh, how we achieve this repetition, or how we achieve this recursion, in the sense by calling a function uh, from its same definition. Okay, when a function calls itself, so suppose we are writing the definition of a function, and in that same definition, if we call that same function, okay, if we call that same function, we call it as the recursion. Okay, don't you bother about if you are not understanding it by statements, by verbal explanation. We'll do some demonstration, some nice demonstration in today's session with examples so that you will understand it very clearly. Okay, so simply remember, recursion is a process in which a function calls itself. Okay, take down this definition if you're preparing the notes. What is recursion? Recursion is a repetitive process in which a function calls itself. So when a function calls itself, while you are writing the definition of a function, you mention, okay, inside the definition itself, you mention the same function call. Then that process will become the repetition. That process will become the recursion. Okay. So hope you understood. Okay. So simply remember, recursion, why we are using recursion? To achieve repetition in our programming. Okay, to achieve repetition in our programming, we use recursion, and it is an alternative approach for loops. Loops are the first means to achieve repetition, and the recursion is the alternative approach or the second approach to achieve repetition in our programming. And what is recursion? That also I defined. Okay, అసలు ఆ రిపీటేషన్ ని, ఆ ప్రాసెస్ ఆఫ్ రిపీటేషన్ ని ఎలా అచీవ్ అవుతామంటే బై మేకింగ్ అ ఫంక్షన్ టు కాల్ ఇట్ సెల్ఫ్. ఓకే, how we are achieving that repetitive process in the sense by making a function to call itself. So that whole thing, technically how it will look like, how a function will call itself, and how that will leads to repetition, that and all practically I will demonstrate. Verbally, if I give verbal explanation, if I give in this whole class, you will not understand. Only with the demonstration, only by seeing how it will actually works, you will understand. Because this particular concept for a beginner to understand a little complicated. Okay, just bear with me before I complete the theory stuff. Then we will enter into practical demonstration, some code explanation. There you will understand more clearly. Okay, so this recursion process, it is not supported by all the programming languages. There are some older languages which do not support the recursion, and COBOL is one such example. Okay, COBOL language, you might be knowing it. COBOL, it is also a programming language like your C programming language, and this COBOL, it will not have the concept of recursion, or we can say this COBOL language will not support the recursion. Okay, recursion process. You just remember this as a statement. Okay, and yeah, to understand, as I said now, to understand the recursion more clearly, we consider different examples. Okay, we do different examples to understand the concept of recursion. Okay, what are they in the sense? As a first step, we'll try to find the factorial of a given number. In mathematics, you might be knowing how we calculate the factorial of a given number. Program wise, okay, by writing the code, how we calculate the factorial, both using loops and using recursion, we try to understand. And the second example, this is the first example. Finding factorial is the first example that we practice. And second example, finding the printing the Fibonacci series up to the given number. We'll read some number, and up to that number, we'll print the Fibonacci series. And what is Fibonacci series? Who invented this? And how the series will look like? What are the terms in your Fibonacci series? That and all we will understand in today's session. Okay, when we do this example. And finally, calculating the GCD. This is the third example which we practice, calculating the GCD of two given numbers. Okay, GCD is nothing but greatest common divisor. GCD stands for greatest common divisor, or we also call it as HCF. GCD anna HCF anna same thing amma. Highest common factor anna leda greatest common divisor anna same thing. Okay, so how to find this GCD or HCF of two numbers through iterative approach as well as through recursive approach, we will try to understand. Okay, so yeah, as the last step, when solving these problem examples, we not just go with recursive approach but also with iterative definition. Okay, we see both iterative definition as well as recursive definition for these three problems. Okay, for these three problems. Okay, let us quickly take the crisp understanding from this slide. So we said in order to achieve the repetition, we have two different approaches. One is loops. We call it as iterative approach. Using loops is nothing but iterative approach. ఇక్కడ iterative definition అని రాశాం కదమ్మా. Iterative definition is nothing but using loops. Through loops we achieve repetition, and that process we call it as iterative definition. Okay, then if you are using function calls to achieve repetition, if you are using function call, if you are using recursion, we call it as recursive definition. Okay, and for all these problems 1 2 3 whatever we set to discuss, for all these three problems we see both iterative definition. Using loops we'll see the solution, and using recursion we'll see the solution. Hopefully you understood ma. So quickly get into the first thing, that is uh, factorial. Finding factorial of a given number. For this we need to understand both approaches, iterative definition as well as recursive definition. Okay, so but before that I'll make you understand with a simple, very simple program. I'll make you understand how this recursion will work. Okay. Okay, I'm taking a very simple a program over here to make you understand. So అసలు recursion అంటే ఏంటి? Why we said that a function is calling itself? Okay, recursion అంటే ఏమన్నాం మనం? A function calling itself. Why we used that term? Okay, when a function calls itself, how that process looks like? Okay, that we try to understand because it is related to what we call functions now. So first let me just explain the iterative thing int main of void. So suppose if I want to print a statement, printf, okay, backslash n hello world. Okay, so what this statement, and then return 0, what this statement will print on output screen. So demo function.c, overwrite it. Okay, what this statement will print, it will print a single hello world message. As you can see, only one time hello world it is printing. So suppose if I want to print this same hello world statement 10 times, okay, 10 times print చేయాలనుకుంటున్నానమ్మా. So in that case what I'll do, I'll take a loop for all. I need to define one counter I. Okay, so I equals to 0, I must be less than 10. 10 we said na, so I must be less than 10, I plus plus, and then this statement has to go inside this loop. So now what will happen? This only statement hello world, it will be repeated how many times? 10 times. The process of repetition. Okay, so the process of repetition, as you can see, how many times we are seeing this hello world? 10 times we are seeing this hello world. So this is what repetition, achieving repetition we say. Okay, so how we achieved this repetition in this particular program? Through loops. Okay, through loops we have achieved this repetition in this particular program. So this approach we call it as iterative definition. Iterative definition అంటాం దీన్ని. ఓకే, ఇదే ప్రాసెస్ ని మనం iterative definition అంటామమ్మా, iterative approach అంటాం. To print, to achieve repetition in our program, we followed the iterative approach. Okay, there is a second approach of doing the same thing, that is through recursion. Okay, through recursion కూడా మనం చేయొచ్చు. Recursion use చేసి, so this whole thing I'll put in comments. So this whole thing I'm keeping in comments. Okay, just for our understanding, I'm writing the same program. I'm writing the code, recursive code in the same program. So what I have to do now, obviously, when I go for a recursion ki velte nenu em cheyalamma. First, I need to declare one function, because complete recursion process, it is dependent on functions only. Okay, I will declare one function, and when I define this function, in that definition I will call this function once again. So that is how it will become a function calling itself. Okay, so what I have to function declaration I'm keeping here, int main of void, come down, and here what you do, just call the function. Okay, I won't do anything, just call the function declaration నేను చేయలేదు. Here I need to do the function declaration. I'm calling my function void, it will not return anything. I'm calling my function as greeting. Okay, greeting, because hello world, it is going to print hello world, so I'm calling it as greeting. So neither it will take any parameter, nor it will return any parameter, nor it will return any return value. So initially we'll go like this, and according to our requirement we will modify. Okay, basically, because if I put like this now, my function will repeat itself, ante our repetition process infinite number of times ki repeat avutundamma. Okay, so I need to do some changes here also, but after understanding what changes we have to do, accordingly we will do the changes. So now what I have to I need to call the function. First I will call this from main only. So call cheyalante em cheyali, just put the function name greeting, that's it. Don't pass anything, don't receive anything. Next, definition. Okay, function definition will go after the main, and here what I have to void greeting of void. Okay, now I will print that message, printf. Okay, printf, put the backslash n, and then your hello world. Hello world. Okay, so now, yeah, this thing, did I call the function from itself? No, I call the function from main. So how this program will execute it will print how many times this hello world? Only one time, because we are calling only one time this greetings here, so it will print only one time. Just see here, compile, run, we are seeing only one time hello world. So now what I'll do is, I'll make these greetings not only from the main, but also to be called from the function definition itself. So now here you can see, this is what? This is the function call. It is nothing but your function call. We have seen so many times this type of signature. Okay, so here my function greetings is calling itself. My function greeting is calling itself. So this is this process, this particular process, we call it as what? Recursion. E process name manam recursion antamamma. Okay, so here whatever I mentioned in my slides, this particular process we call it as recursion. Okay, so hopefully you understood. So now what will happen? We made the function to call itself without any control. We haven't put any control on it. So how this repetition will continue? How this repetition will continue? See, first what will happen? The program enters into the main. We have called the greeting. So the control jumps from this point to this point. ఫంక్షన్ కాల్ వచ్చిందంటే కంపల్సరీగా కంట్రోల్ ఎక్కడికి జంప్ అవుతుందమ్మా? ఫంక్షన్ డెఫినేషన్ కి జంప్ అవుతుంది. గుర్తు పెట్టుకోండి, ఫంక్షన్ కాల్ వచ్చిందంటే కంట్రోల్ ఫంక్షన్ డెఫినేషన్ కి జంప్ అవుతుంది. సో ద కంట్రోల్ విల్ జంప్ ఫ్రమ్ హియర్ టు హియర్, అండ్ ఇన్సైడ్ ఇట్ వాట్ we have this statement to print hello world. This will be printed on the output screen. After that what we have the function call again. After this we have the function call again. So what will happen? Whenever the function call is there, the control, where it will jump? It will jump to the function definition. Again, where we have that function definition? Here we have that function definition. So after seeing this function call, the function control, the program control jumps to the function definition. And again it will enter it will print hello world, again the call, again go to the definition. Like this it will repeat here itself. And how many times it will repeat? Because we haven't put any control ma. So this will repeat for infinite number of times. How many times it will repeat? For infinite number of times this will repeat itself. Hope you understood. Okay, hope you understood. And we will execute this to understand. Compile it. As you can see, it is successfully compiled. Then run it. You can see here how many times it is printing. It is keep on printing itself. It is keep on printing itself. See, thousands of times it has printed already. Okay, thousands of times it has printed already. So it is keep on printing itself. So just to see, because here it is we are unable to differentiate. Just to see the difference, what I'll do is I'll declare a global variable ma. I'll declare a global variable here, int I. Okay, so that I can use in all the functions. Okay, so I'm declaring it I as a variable globally, and I'm initializing this I with 1. And what I'll do here, I print the I value. After hello world, I'm printing the I value. So I, and inside this only I will try to modify the I. Okay, I don't know whether it will give us or not, but because I have declared globally, so I have to get. So just to see how this repetition process is continuing, because infinite times how this repetition process is continuing, I'm printing I also. So let's just see. Yes, as you can see, already it is crossed 40,000 something, and it is automatically braked. Okay, automatically got braked because we have a kind of we should not consider it as a programming break. It is from the operating system. Okay, because instead of making your CPU too busy, the operating system has concluded this one. Okay, the operating system, after 5 or 6 seconds, as it is continually running, so the operating system itself has stopped this repetition process. So hope you understood how this will go. Okay, how this repetition is happening, how we are getting this repetition through iteration. Hope you understood. Okay, so this particular process, whatever I kept over here, this particular process we call it as a repetition, recursion. Okay, through which we are achieving repetition. Okay, so now we need to put some control we need to put some control on this recursion process or repetition process, so that the recursion process or the repetition process terminates after some n number of steps. So how we do that, in the sense, just read one counter, int say n. Okay, and printf enter number of steps. Okay, enter number of steps and read that thing into what we call n variable. Okay, so next is just pass it. When you are invoking the function, just pass it. When you are calling the function, just pass that value. Here it is no more void, it is int now. Okay, it is int now, and here what you do, receive that into n itself. Okay, here this n is actual and this n is formal, and what you do is, when you are calling recursively, just made it as n minus 1. That's it, just made it as n minus 1. And here in the function definition itself, when the I value, or when if n value goes to 0, it has to be greater than 0. Okay, it has to be greater than 0. Or how we can, it has to be greater than 0, otherwise we need to break. So what I'll do is, shall we make it less than, if n value goes equals to 0, then break. Equals to 0, then break. We'll see like this whether it will work or not, or I think we need to call exit here. We will see first like this whether it will work or not. Just compile it. Yeah, improper break. Here it should be exit. And for this exit, we need to give a prototype, that is stdlib.h. Because if you give like this now, just see the error, what error it will give. Compile, see here. Incompatible, implicit declaration of built-in function exit, because this exit, it is not there in your stdio.h. We have a separate library for that one, that is stdlib, standard library.h. So now this error, hopefully it will go off. Yeah, as you can see, it is not showing it, that error. Just compile it. It is asking me to input the number of steps. So if I say 8, if I say 5, no, it is not working. It is still in the infinite loop. Here we are passing n. Is there any mistake in the reading process? Okay, for some reason it is printing -1. It should not go to -1. Here we have said exit when n value is equals to 0. Okay, so there is some issue. Okay, we will see the factorial example. There you will understand. Yeah, in the recursive, in the iterative approach, finding the factorial of a given number, we know that whenever we calculate the factorial, say suppose n factorial we are calculating, what we have to do, we need to multiply all the numbers starting from 1 to that n, isn't it? So that is how we calculate the factorial. So here 1 multiplied 2 multiplied 3 and so on up to, we need to continue this multiplication process up to n. Okay, and whatever result we will get now, that result we consider as the factorial of n. Say suppose if we are calculating 4 factorial, how it will be? 1 multiplied 2 multiplied 3 multiplied 4, and 4 3 is 12, 2 is 24. So this will be 24. Like this we calculate the factorial in mathematical. So this particular thing we can achieve in two different ways. Calculating the factorial of a given number we can achieve in two different ways. One is through iterative definition, which we discuss in this particular slide, and one is through recursive definition, okay, which we discuss over here. So if you see the iterative definition for finding the factorial of a given number, what we have to factorial of n, it will be 1 if n value is equals to 0, because 0 factorial, we know that 0 factorial will be 1 only. Okay, so yeah, here I have written the definition. The factorial of n, it is 1 if n value is equals to 0. It will be something this whole thing. Okay, it will be something this whole if n value is greater than 0. Okay, n value 0 కాకుండా పాజిటివ్ ఇంటీజర్ ఏది అయినా మనం ఈ పర్టిక్యులర్ ఫార్ములాని యూస్ చేయాలమ్మా. We need to multiply all the numbers starting from 1 till that. Here just we have given in reverse order. Okay, we need to multiply all the numbers starting from 1 till that number, so that to get the factorial of that number. Okay, so we call this type of definition as iterative definition. Okay, iterative definition to find the factorial. Okay, there is another approach, we know that recursion. Okay, that we will see in our next slide. Okay, so here what we are doing, we are calculating the factorial. In this particular example, you can see we are calculating the factorial of 4. So what we did, 4 multiplied with, see here we said n multiplied with n minus 1 multiplied with n minus 2, such that till what extent we have to go, till the value of n becomes 1. Okay, till that extent we have to go. So first we need to multiply with 4, then 3, then 2, then 1. So we will get 24. So that is what factorial of 4 is 24. And in the recursive process, here you need to focus, you need to consider the definitions only. Okay, ఇక్కడ ఎలాగైతే మనం ఈ ఫార్ములే కైండ్ ఆఫ్ థింగ్ రాశామో దీనిపైనే ఫోకస్ చేయండి అమ్మా, ఇది ఎలా చేంజ్ అవుతుందో. ఓకే, సో హియర్ యూ కెన్ సీ, a function is defined recursively whenever the function itself appears within the definition itself. So మనం ఏం చేస్తాం, within the definition ఆ same function ని కాల్ చేస్తాం. That is what the process of recursion means. Okay, so a recursive definition of a recursive definition to find the factorial of a given number is given here. Just see, factorial of n, it will be 1 when n value is 0. n value 0 అయినప్పుడు మనకు ఫ్యాక్టోరియల్ వచ్చేసి 1 వస్తుంది. n value 0 కానప్పుడు, if it is greater than 0, any positive integer, then what we have to do, n multiplied with factorial of n minus 1. Simply మనం ఏం చేస్తున్నాం, n నుంచి ఒక వాల్యూని మైనస్ చేస్తున్నాం. That is what we did in our previous example, but for some reason, I think some mistake I have done in that program, because of that it is not getting. Anyhow, we will try to resolve it. So n multiplied with factorial of n minus 1. Simply we have to do this to achieve the control. If I don't put this n minus 1 over here, if I put n multiplied with factorial of n, again it will enter into infinite loop. So to avoid entering into infinite loop, what we have to do, we need to make something like this, n multiplied with factorial of n minus 1, so as to make the control over that repetition process. Otherwise it will enter into infinity. So simply remember, factorial of n, recursive approach, when n value goes to 0 it is 1, and when n value is greater than 1, n into recursive call of that one, n into factorial of n minus 1, recursive call but with one less value. Okay, that is what here మీరు ఈ పర్టికులర్ రికర్సివ్ డెఫినేషన్ ని ఐటరేటివ్ డెఫినేషన్ తో కంపేర్ చేస్తే అక్కడ ఏం చేస్తున్నాం మనం, n multiplied with n minus 1 multiplied with n minus 2 చేస్తున్నాం. So here also something like that only goes on, but instead of simply n minus 1, we said recursive call of n minus 1. Okay, n multiplied with recursive call of n minus 1, and n minus 1 call అయినప్పుడు n minus 2 వస్తుంది, n minus 2 call అయినప్పుడు n minus 3 వస్తుంది. Likewise, this whole thing will be repeated. Okay, more elaborately here you can see. Suppose if you are calculating the factorial of 3, let us understand, we are calculating the factorial of 3. Factorial of 3 ఎలా వస్తుందమ్మా, factorial of 3 రావాలంటే మనం ఏం చేయాలి, ఫస్ట్ factorial of 3 is equals to n into n minus 1 కదా. So 3 multiplied with factorial of n minus 1, that is nothing but factorial of 2. ఫ్యాక్టోరియల్ ఆఫ్ 2 మళ్ళీ సేమ్ డెఫినేషన్ కాల్ అవుతుందమ్మా, బట్ విత్ వన్ లెస్ వాల్యూ. మళ్ళీ సేమ్ ఫంక్షన్ డెఫినేషన్ కాల్ అవుతుంది, బట్ విత్ వన్ లెస్ వాల్యూ. సో ఫ్యాక్టోరియల్ ఆఫ్ 2. ఫ్యాక్టోరియల్ ఆఫ్ 2 అంటే ఏంటి? అగైన్ టు రిప్లేస్ దిస్ థింగ్ వాట్ ఐ నీడ్ ఫ్యాక్టోరియల్ ఆఫ్ 2. ఇక్కడ ఈ పర్టికులర్ థింగ్ ని రిప్లేస్ చేయాలి అంటే I need factorial of 2. Factorial of 2, how I am calculating? Again, 2 multiplied with factorial of 2 minus 1. That is nothing but factorial of 1. Okay. So here 2 multiplied with factorial of 1. Again, this thing to be replaced with factorial of 1. So factorial of 1 calculate cheyali ante malli I need to depend on that same definition. So factorial of 1 is equals to 1 multiplied, n multiplied with n minus 1. So 1 multiplied with factorial of 1 minus 1, that is factorial of 0. So factorial of 0, we know that. Factorial of 0 enta 1. So here we have that. Factorial of 0, 1 అని పెట్టేస్తాం. So factorial of 0, 1 will be replaced, and the same thing, ఈ particular place లో ఏం చేస్తాం మనం? 1 ని replace చేస్తాం. Here you can see 1 multiplied with 1. So this factorial of 1 will become what? Again, factorial of 1 will also become 1 only. So ఈ particular place 1 తో replace అయింది, and ఈ particular place దేంతో replace అవుతుంది? Again, this will be replaced with 1 only. You can see here. Factorial of 2 is equals to 2 multiplied with 1. Okay, 2 multiplied with 1. So now we got factorial of 2 as 2. So this whole thing will be replaced with what? Factorial of 2. Factorial of 2 మనకి ఎంత వచ్చింది? 2 వచ్చింది. So now that you keep here 2. So now factorial of 3 will be 3 multiplied with 2. So you will get 6. So this is how we calculate the factorial in recursive approach. Simply రికర్సివ్ డెఫినేషన్ రాసేటప్పుడు మనం ఏం చేస్తున్నాం? రికర్సివ్ కాల్ చేసేటప్పుడు ఆ n వాల్యూ ఏదైతే ఉంటుందో దాన్ని -1 చేసి కాల్ చేస్తాం, అంతే. -1 చేసి కాల్ చేస్తే మనకు ఆ పర్టికులర్ కాల్ నే మనం రికర్సివ్ కాల్ అంటాం. ఆ -1 చేయకుండా కాల్ చేస్తే ద లూప్ విల్ ఎంటర్ ఇంటూ ఇన్ఫినిటీ. ఆ -1 చేసి కాల్ చేస్తేనే మనకు ఒక కంట్రోల్ అనేది ఉంటుంది. ఓకే, hopefully you understood this particular thing. So just we'll see the program solutions ma, calculating the factorial with iterative approach. Here what we did in iterative approach ante loop use chesi factorial ni call chesam ikkada. Loop use chesi factorial ni call chesam. So here you can see clearly we have declared two variables n and result, and I am reading the number to which we calculate the factorial, and I am storing that into n లో ఆ నంబర్ ని రీడ్ చేస్తున్నాను. దెన్ రిజల్ట్ ఈక్వల్స్ టు iterative factorial of n. I'm calling a function iterative factorial. You can see the declaration over here. This function will take an integer value and return an integer value. Okay, so now after this function call, the control jumps from here to here, and whatever n value I am passing, that n value will come inside num. ఓకే, ఈ n వాల్యూ ఎక్కడ వస్తుందమ్మా? నమ్ లో వస్తుంది. నౌ ఇంటర్నల్ టు దిస్ జస్ట్ ఐఎమ్ రన్నింగ్ అ లూప్ స్టార్టింగ్ ఫ్రమ్ 1 టిల్ దట్ నంబర్. ఓకే, టిల్ దట్ నంబర్ ఐఎమ్ రన్నింగ్ ద లూప్. సో 1 నుంచి స్టార్ట్ అవుతుంది అండ్ ఆ నంబర్ వరకు వెళ్తుంది, అండ్ ఎవ్రీ టైమ్ ఐఎమ్ ఇంక్రిమెంటింగ్ ది ఐ వాల్యూ బై 1. ఓకే, అండ్ ఐఎమ్ క్యాల్కులేటింగ్ ఫ్యాక్ట్ ఈక్వల్స్ టు ఫ్యాక్ట్ మల్టిప్లైడ్ విత్ ఐ. So initially fact value ఎంత ఉంది? 1 ఉంది. So 1 multiplied with I value 1 వచ్చింది. Let us assume, to understand this, let us assume n value as 4. Okay, మరీ పెద్ద వాల్యూ తీసుకోకండమ్మా, క్యాల్కులేషన్ ప్రాబ్లం అవుతుంది. n is equals to 4, just for our understanding. n is equals to 4. Then here 4 we will read, and that 4 will be passed as an actual parameter here, and it will be copied into this num as a formal parameter. Now num will become 4. Okay, num is 4 in the called portion. Num is equals to 4. Then what we have done here, we took one variable fact equals to 1 తీసుకున్నాము, I అని డిక్లేర్ చేశాము, లూప్ లో I వాల్యూ ని 1 కి ఇనిషియలైజ్ చేస్తున్నాం. Here you can see. So then I value will be compared. I less than or equals to num ఎంత? 4. I less than or equals to 4, condition true. So we are calculating the factorial. Fact equals to fact multiplied with I. What is fact? 1. What is I? 1. 1 multiplied with 1. Fact ఎంత అవుతుంది? 1 అవుతుంది. We are not changing any fact. Okay, just this 1 will be replaced with 1 only. Okay, then go back, as it is a loop, go back and increment I value. I value now it will be 2. Okay, so then 2 less than or equals to 4, condition true. Okay, Then fact ఎంత ఉంది 1. 1 multiplied with 2. 1 multiplied with 2. How much it is? 2. So that 2 we are keeping in fact only. The 2 we are keeping in fact. So fact will become 2 now. Okay. Next thing, I value, as it is a loop, I value gets incremented. I value becomes 3 now. 3 less than or equals to 4 because num is 4. 3 less than or equals to 4, condition true. Then control enters, control calculates the new factorial, new fact. Fact equals to old fact. What was it? 3. 3 multiplied with uh, old fact is 2 ma, not 3. 2. You can see here 2 multiplied with I value. I value is 3 now. So 2 multiplied with 3. Fact will become 6 now. Okay, fact will become 6 now. Again, last iteration, one more iteration. I value gets incremented. I value becomes 4 now. Okay, I value becomes 4 now. So 4 less than or equals to, we said less than or equals to 4, condition true. We are calculating the new factorial. Old factorial is 6 multiplied with 4. 6 multiplied 4, 24. That 24 we are storing into fact only. So my fact will become now 24. Not this one, ma. Sorry. Here it will become 24 now. My fact will become 24 now. So after that, I value gets incremented. I value becomes 5 now. 5 less than or equals to 4. Condition false. Control exits and returns fact. What is fact? 24. ఈ 24 ఇక్కడ నుంచి రిటర్న్ అవుతుంది. And where it will go? To the function call it will go. Here we call that function. So 24 will come over here and the same thing will be initialized to result. And factorial of percentile d is percentile d. n వాల్యూ ఎంత రీడ్ చేశామమ్మా, యాక్చువల్ పారామీటర్ ఉంది కాబట్టి చేంజ్ అవ్వదు. 4 రీడ్ చేశాం, 4 యాజ్ ఇట్ ఈజ్ ఉంటుంది. ఈ 4 ఇక్కడ ప్రింట్ అవుతుంది అండ్ రిజల్ట్ వాల్యూ ఎంత రిసీవ్ అయింది? 24 రిసీవ్ అయింది. సో దిస్ 24 విల్ బి ప్రింటెడ్ ఓవర్ హియర్. సో వాట్ వి సీ ఆన్ ది అవుట్పుట్ స్క్రీన్, factorial of 4 is 24. That is what we will see over here when we execute. Hopefully you understood this concept, this logic. Very simple program. So the same thing, recursive definition, recursive solution. As you can see here, what we are doing, ma? We are reading n and result as we have done in our previous example, and we are using a function recursive factorial with input as int, output as int. My function will take one parameter of integer type, return one parameter of integer type. Okay, so here I am reading the number to which we calculate the factorial and I am storing into n. Okay, then I am calling the function. So this n, say suppose read cheyandi, again to understand this recursive definition, n value 4 ఇన్పుట్ చేస్తున్నాను అనుకోండి. సేమ్ థింగ్ ప్రీవియస్ ఐటరేటివ్ లో ఎలాగైతే ఇన్పుట్ చేశానో ఇక్కడ కూడా అదే ఇన్పుట్ చేస్తున్నాను అనుకోండి. దెన్ 4 విల్ బి పాస్డ్ హియర్. ఓకే, యాక్చువల్ పారామీటర్, యాజ్ అన్ యాక్చువల్ పారామీటర్ 4 విల్ బి పాస్డ్ అండ్ సేమ్ థింగ్ విల్ బి రెడ్ ఇంటూ num, formal parameter. So num inside the function definition, num will become 4 ma. Num will become 4. Okay, then we are checking if num equals to 0. Yeah, in my program I have done the mistake here. I have done the mistake. I am checking the condition ma here. I am not initializing n value. I need to check the condition. So double equals to I have to put. So that was the problem. So if I say 5, see it is printing. Okay, it is printing 6 times. So what I have to do here? When it is becoming 1, there only I have to stop. That's it. Compile, run. If I am printing 5 times only it will print. 5, 4, 3, 2, 1. Likewise, this is how we can control. Okay, this equals to symbol only I did the mistake ma previously. Now come back to here. So here 4 we passed and this 4 we read into num, into this variable num. And here we are simply checking if num is equals to 0 or not. As we know, num is not equals to 0, will not return 1. Okay, will not return 1. Rather, we'll go to the else part, and inside the else part, what I am doing, ma? Just observe this carefully, ma. Inside the else part, I am calculating num, that is 4. ఇక్కడ ఏం నమ్ వాల్యూ ఎంత వస్తుంది 4 వస్తుంది 4 multiplied with same function I'm calling from this function. So this is recursion. ఓకే రికర్సివ్ కాల్ చేస్తున్నానమ్మా రికర్సివ్ కాల్ దేంతో చేస్తున్నాను నమ్ మైనస్ 1 తోటి చేస్తున్నాను సో రికర్సివ్ ఫ్యాక్ట్ ఆఫ్ నమ్ మైనస్ 1 నమ్ మైనస్ 1 అంటే ఎంత పెట్టి కాల్ అవుతుంది అక్కడ హౌ మచ్ వాల్యూ పాస్ అవుతుంది ఇక్కడ 3 పాస్ అవుతుందమ్మా అండ్ ఇఫ్ యాజ్ యూ హ్యావ్ ది ఫంక్షన్ కాల్ ఓవర్ హియర్ ఇక్కడ నుంచి కంట్రోల్ ఎక్కడికి జంప్ అవుతుంది డెఫినేషన్ కి జంప్ అవుతుంది బట్ డెఫినేషన్ కి జంప్ అయినప్పుడు నమ్ వాల్యూ ఎంత ప్లేస్ అవుతుంది 4 ప్లేస్ అవ్వదమ్మా 3 ప్లేస్ అవుతుంది ఎందుకంటే వి సెడ్ నమ్ మైనస్ 1 ఓకే సో నౌ ఫర్ దిస్ కాల్ ఫర్ దిస్ ఫంక్షన్ కాల్ n value will be 3 num value will be 3 do understand and remember for this recursive call num value will be 3 okay with num value 3 again it will be compared and checked it will be compared and checked is it 0 num value is it 0 no it will go to the else part and same thing will be evaluated once again num multiplied with recursive factorial of num minus 1 now my num is how much 3 so for this call 3 multiplied with recursive call recursive fact of 3 minus 1 isn't it 3 minus 1 so how much it is 2 this time okay for this num value will be 2 okay and again as we have the function call again the control goes to the definition but this time num value is 2 with 2 value again it is compared with 0 it is not 0 so it is it goes to the return part and return part lo again manam num multiplied with recursive factorial of num minus 1 so what is num now 2 2 multiplied with recursive factorial of 2 minus 1 2 minus 1 how much 1 okay 2 minus 1 that is nothing but 1 and again as you can see it is a call function call only so where the control goes to the definition only but this time num value is 1 okay again it is compared with 0 it is not 0 so again it will go to the return part, else part lo num multiplied with recursive fact of num minus 1 so what is num now for this num is 1 num is equals to 1 now so 1 multiplied with recursive fact of 1 minus 1 how much it is 1 minus 1 ante 0 okay this is one more time function call only this is one more time function call only so where the control goes here the control goes but now num value is 0 okay but now num value is 0 so again num value is compared with 0 0 equals to 0 condition true ma this time condition true అవుతుంది కాబట్టి this time ఎంత రిటర్న్ అవుతుంది 1 రిటర్న్ అవుతుంది and the control will not go to the else part it will return 1 now so that one where it will come to the function call that one will come function call ఎక్కడి నుంచి వచ్చిందమ్మా ఇక్కడ నుంచి వచ్చింది so 1 will come here okay 1 will come here so ఈ 2 మల్టిప్లై అవుతాయి ఈ 2 మల్టిప్లై అయినప్పుడు మనకు రిజల్ట్ ఎంత 1 ఆ 1 ఎక్కడికి వెళ్తుంది ఈ పర్టిక్యులర్ కాల్ కి వెళ్తుంది ఈ పర్టిక్యులర్ కాల్ లో 1 రిజల్ట్ వెళ్తుంది okay and this 1 will be multiplied with 2 2 multiplied with 1 how much 2 and that 2 where it will go to the recursive factorial of 2 okay so 2 will come here result value 2 will come here and then this 2 will be multiplied with this 3 3 multiplied with 2 how much 6 that 6 where it will go to the recursive factorial of 3 6 ఇక్కడికి వస్తుంది result value 6 ఇక్కడికి వస్తుంది then 6 multiplied with 4 how much it is 24 ma that 24 will be printed on the output screen okay straight away it will come to the recursive factorial of 4 here we have the recursive factorial of 4 as you can see so this 24 6 multiplied with 24 that is 24 where it will come here it will come and it will be stored into result ఈ రిజల్ట్ లోకి స్టోర్ అయిపోతుంది and the same thing you will see here actual n value 4 ఏ ఉంది కాబట్టి 4 24 here you will see 4 here you will see 24 I hope you understood so this is how it will work so ikkada meeku detailed explanation undamma you can see factorial of 3 we are calling which in turns make factorial of 2 which in turn makes factorial of 1 which in turn makes factorial of 0 so when n value goes to 0 control comes over here and returns 1 and this one will be multiplied with 1 so 1 plus 1 1 only. So this one goes here. Then here 2. 2 multiplied with 1, 2. This 2 will go to here. Here 3. 3 multiplied with 2, 6. 6 goes to here. Like this it will calculate. 3 factorial ante 6 ila calculate avutundamma. Hope you understood. First it will go from top to bottom, then it will go from bottom to top. Evaluation ఎలా ఉంటుందమ్మా? First it will come from top to bottom. Recursive calls ఎలా తీసుకొస్తాయి? Top to bottom తీసుకొస్తాయి. And results ఎక్కడికి తీసుకొని వెళ్తాయి? Bottom to top కి తీసుకొని వెళ్తాయి. Every time it will calculate one result and it will go from bottom to top until you get the final solution here. Hope you understood, ma. You can execute these programs. They are not that much complex, easy to understand. Recursive iterative definitions very easy to understand. Recursive definitions somewhat will take the energy, ma, your effort. Okay, so hope you will execute these two programs and get the solution. And then we have the Fibonacci series thing, Fibonacci numbers or Fibonacci series. Just to understand this, it is another example of recursion. Printing Fibonacci numbers or Fibonacci series, it is another example of recursion. So yeah, Fibonacci Fibonacci series is a series in which each number is the sum of previous two numbers, ma. You remember like this only. Okay, Fibonacci series is a series in which each number is the sum of previous two numbers and where the starting two numbers are 0 and 1, as you can see here. The starting two numbers are fixed in the Fibonacci series and they are 0 and 1. Okay, starting two numbers are 0 and 1 and every other number after these first two numbers, every other number is the sum of previous two numbers. So here these two 0 and 1, they are fixed. This is the first number, this is the second number, and third number is the sum of first two, previous two, that is 0 plus 1. How much it is? 1 only. And fourth number, sum of previous two, that is 1 plus 1. Fifth number, sum of previous two, 2 plus 1, 3. Okay, 3 plus 2, 5. 5 plus 3, 8. 8 plus 5, 13. 13 plus 8, 21. 21 plus 13, 34. Likewise, the series continues, where every number in the Fibonacci series is the sum of previous two numbers. Like this, you remember. Okay, and why we got this name Fibonacci to this series, in the sense this series was given by a famous mathematician, Italian mathematician with name Leonardo Fibonacci. In the 13th century he did this one, ma. He gave this concept, Fibonacci series concept. Okay, so the scientist, the mathematician, Italian mathematician name was Leonardo Fibonacci. Here it is given, Leonardo Fibonacci, and in the 13th century he gave this Fibonacci series, and he is from Italy, so we are calling him as Italian mathematician. Okay, so we know that the starting two numbers, the first two numbers in the Fibonacci series will be 0 and 1, and the remaining all numbers, it is the sum of previous two numbers, ma. A number తీసుకున్న sum of previous two numbers ఉంటుంది మీ Fibonacci series లో. Okay, so that conclusion, how we can write in the sense, see here, given that Fibonacci of 0, that is the first term in the Fibonacci series, 0, and second term in the Fibonacci series, that is Fibonacci of 1, 1. How we can calculate nth term, in the sense, simply we need to sum up the Fibonacci of n minus 1, the previous two terms, n minus 1 and n minus 2, previous two terms. If you say this as nth term, then this will become n minus 1th term and this will become n minus 2 term. Okay, nth term దీన్ని అనుకుంటే ఇదేమవుతుంది, n minus 1 term అవుతుంది, n minus 2 term అవుతుంది. So simply to calculate nth term, what we have to do, we need to add these two. Okay, we need to add these two, n minus 1th term and n minus 2 term. So that will be 2 plus 1 and we get the 3, nth term. Okay, ఈ పర్టికులర్ ఫార్ములాని గుర్తుపెట్టుకోండి, because this formula is going to help us in defining the recursive definition. Recursive definition ఇవ్వడానికి ఈ ఫార్ములా మనకు హెల్ప్ఫుల్ అవుతుంది. Just remember this formula. Okay, so Fibonacci, how we calculate, in the sense, Fibonacci of n is equals to Fibonacci of n minus 1 plus Fibonacci of n minus 2. Like this, you remember, ma. Okay, hopefully it is clear. The Fibonacci series, very easy thing, and the definition also very easy. So iteratively, yeah, recursively, how we calculate in the sense Fibonacci of 4 to calculate. Let us suppose Fibonacci of fourth term you are calculating. What you have to do? Fibonacci of 3 plus Fibonacci of 2 చేయాల్సి వస్తుంది. And Fibonacci of 3 కావాలి అంటే Fibonacci of 2 plus Fibonacci 1 చేయాల్సి వస్తుంది. We know that Fibonacci of 1 is 1 only. Fibonacci of 2 calculate చేయాలి అంటే Fibonacci of 1 plus Fibonacci of 0 చేయాల్సి వస్తుంది. We know that Fibonacci of 1 is 1 and Fibonacci of 0 is 0. So recursive definition ఎప్పుడు కూడా always it will take from top to bottom. Okay, and solutions they will take us from bottom to top, because we got the solution here. Fibonacci of 1 is 1 and Fibonacci of 0 is 0. So if you add these two, you will get the Fibonacci of 2. 1 plus 0, 2 ఇక్కడ వచ్చేస్తుంది. Likewise we calculate. So here the iterative solution we have given to the Fibonacci series. Yeah, we took one function which is taking integer parameter but not returning anything. Okay, and here the number of terms, how many terms you want in the Fibonacci series, that I am reading into n, and simply by passing that n to the function I am calling the function. Okay, so this is my actual parameter and will be copied into formal. Okay, ఇక్కడ n pass అవుతుంది and n ఇక్కడ వచ్చేస్తుంది, and here I am printing the Fibonacci series using a loop. As you can see, I'm not calling any recursive function over here. Okay, I'm simply printing using a loop because we are seeing the iterative solution now. So what I have done, I took one I, term 1, the first term, yeah, you can make it as term 0, term 1 likewise, but we made it as term 1 as 0 and term 2 as 1 and next term. ఓకే, సింపుల్ గా మనం ఏం చేస్తాం, ఫస్ట్ టూ టర్మ్స్ ని ప్రింట్ చేసేసి ఆఫ్టర్ దట్ వి క్యాల్కులేట్ ది నెక్స్ట్ టర్మ్. ఓకే, ఎవ్రీ టైమ్ వి క్యాల్కులేట్ ది నెక్స్ట్ టర్మ్. ఓకే, సో హియర్ ఐల్ రైట్ దట్ వన్. ఐ వాల్యూ రాస్తున్నాను, టర్మ్ 1 రాస్తున్నాను, ఈజీ టు అండర్స్టాండ్. మా టర్మ్ 1 రాస్తున్నాను, టర్మ్ 1 వి ఇనిషియలైజ్ టు 0. Okay, I value inside the loop we initialize to 1, that I will write. Term 1 rastunnanu, that is 0, and term 2 it is 1. Okay, and we are calculating the next term and we are printing it. Next term calculate chesi print chestunnam. Okay, so simply the control enters, I value will be initialized to 1, then I value will be compared with n. N enta, let us assume n as 5. Number of terms that I need as 5. Okay, so n will become 5. So I value is 1, I less than or equals to n, I less than or equals to 5. Condition is true, then percentile d, term 1 I am printing. First term I am printing. So what is term 1? 0. So you will see on the output 0, then as you can see comma I kept over here, so you will see comma also. 0 comma. Then what I am doing? I am calculating the next term by adding the term 1 plus term 2. What is term 1? 0. What is term 2? 1. So 0 plus 1, how much it is? 1. So I am calculating the next term as 1. So my next term will become 1. Here you put that one, 1. Then I am replacing term 1 with term 2. Term 1 lo entundi manaku 0 undi, term 2 lo entundi 1 undi. So I am replacing this 0 with 1. Okay, then I am making term 2 as next term lo entundi 1 undi. I am making term 2 as 1. Okay, next thing, the control goes back and checks the condition, updates the I value will become 2 now. Okay, and checks the condition, 2 less than or equals to n, condition true because n is 5. And now again I am printing term 1. Term 1 ni print chestunnanu. So what is the value of term 1? 1. So I will see 1 over here on the output screen. Then again I am calculating next term. Next term is equals to term 1. How much it is? 1 plus term 2. It is also 1. So next term will become 2 now. 1 plus 1, 2 అయిపోతుంది. Then I am making my term 1 as term 2. Term 1 ni term 2 లో ఉన్న వాల్యూ తోటి అసైన్ చేస్తున్నాను. టర్మ్ 1 లో 1 ఉంది కాబట్టి 1 అయిపోతుంది టర్మ్ 1. Then I am making term 2 as next term. Here term 2 next term. Term 2 లో ఎంత ఉంది? 1 ఉంది. Term next term లో 2 ఉంది. So this 1 will be replaced with 2 now. Okay. Again, the control goes back and I value gets updated. I value becomes 3 now. I value 3 now. 3 less than or equals to 5, condition true. Once again, next term, term 1 print avutundi. Term 1, how much we have? 1 only we have. So 1 it will print. Again, next term calculate avutundi by adding previous two terms. That is term 1 plus term 2. So what is term 1? 1. What is term 2? 2. 1 plus 2? 3. Okay. Then we'll make term 1 as term 2. So here 2 will come. Then we'll make term 2 as next term. 3 will come over here. Okay. Then one more iteration. I value gets updated. I value becomes 4 now. Okay. I value becomes 4 now. But now we are printing the term 1. So how much value term 1 is having? 2 it is having. Comma, it will print 2. Likewise, in the next iteration, it will print 3 also. 2 plus 1, 3. So already 5 terms are over. So the loop will break because I value goes past 5. 5 అవుతుంది. 5 అయినప్పుడు కూడా మనకు 3 ప్రింట్ అవుతుంది. 5 పాస్ట్ వెళ్ళినప్పుడు 6 అయినప్పుడు మనకి ఇక్కడ లూప్ బ్రేక్ అయిపోతుంది. As you can see, here the loop will break. So when you give the number of terms to print as 5 in the Fibonacci series, you will get 0, 1, 1, 2, 3 only. Okay. So here I took number of terms as 9. So I got up to 21 in my Fibonacci series. So this is the iterative solution. We have recursive solution also here. You can see recursive ga ela call chestunnamo chudandamma. Every time whenever we are calculating the new term in the Fibonacci series, what we are doing? n minus 1 plus n minus 2. Edaithe definition manam chusamo, Fibonacci series definition edaithe chusamo, that definition we are utilizing over here. And these two functions, recursive fib, we are calling recursively because they are inside the definition of recursive fib itself. Okay. So first we are passing n, and then if it is 0 and if it is 1, we are returning the same thing. Okay. If it is 0, we are returning the same thing, and if it is 1, we are returning the same thing. But if it is anything other than 0 and 1, we are calculating the recursive, we are calculating the term recursively. Okay. This also you can easily, yeah, this particular thing ma, ఇది ఇక్కడ ఏదైతే డెఫినేషన్ ఉందో ఈ పర్టికులర్ పిక్చర్ చూస్తే మనకు అర్థమవుతుంది. Assume that we are calculating the recursive definition of, we are calculating the Fibonacci of 4. Fibonacci of 4 calculate చేస్తున్నారు అనుకోండి. So how I have to calculate ma? Here you can see n minus 1, n minus 2, n minus 1 plus n minus 2. So recursive 4 calculate చేస్తున్నప్పుడు n minus 1 ఎంత అవుతుంది? Fibonacci of 3 అవుతుంది. What it will be ma? Fibonacci of 3 it will be here. And Fibonacci of 4 calculate చేస్తున్నప్పుడు n minus 2 అంటే ఎంత అవుతుంది? Fibonacci of 2 అవుతుంది. So again Fibonacci of 3 calculate చేస్తున్నప్పుడు again we have to go with Fibonacci of n minus 1 plus n minus 2. So n minus 1 అంటే Fibonacci 2 అవుతుంది. n minus 2 అంటే Fibonacci 1 అవుతుంది. సో Fibonacci 1 అంటే మనకు డైరెక్ట్ గా Fibonacci 1 అంటే n వాల్యూ 1 అయినప్పుడు మనకు ఎంత రిటర్న్ అవుతుంది? 1 రిటర్న్ అవుతుంది. సో we will get 1. Fibonacci 2 అయినప్పుడు again we have to go with Fibonacci of 1 plus Fibonacci of n minus 1 plus Fibonacci of n minus 2. So Fibonacci of n minus 1 is nothing but Fibonacci of 1. Fibonacci of n minus 2 is nothing but Fibonacci of 0. So Fibonacci of 1 ఉన్నప్పుడు మనకు 1 రిటర్న్ అవుతుంది. Fibonacci of 0 ఉన్నప్పుడు 0 రిటర్న్ అవుతుంది. That we have seen here ma. 1 ఉంటే 1 రిటర్న్ అవుతుంది. n is equals to 1 అయితే 1 రిటర్న్ అవుతుంది. n is equals to 0 అయితే 0 రిటర్న్ అవుతుంది. So that is how we are printing the Fibonacci term recursively. Fibonacci terms recursively. Easy to understand my definition. No confusion. Easy to understand. Just we need to be clear how these definitions are going recursively. Okay. How these definitions are going recursively, we need to understand. Okay. And the last one, finding GCD, greatest common divisor. How we will find the greatest common divisor or highest common factor, that particular thing. So we know that this greatest common divisor, the number which exactly divides both and have the common factor. Okay. So suppose if we have 4 comma 12. Okay. Take these two, 4, 12. So we know that 1 will divide both, isn't it? 1 will divide 4 as well as 2. So దీన్ని ఎలా I think you might have done this exercise you might have done in your elementary schooling, finding the highest common divisor or greatest common divisor or highest common factor. You might have done it in your school level. Okay, so what we need to write the factors of 4, and then we need to write the factors of 12, and we need to identify which one is the highest, and that will become the GCD, greatest common divisor. Okay, so here the factors of 4, 1, 2, 4, and the factors of 12, 1, 2, 4, 6, 12. And what will be the common highest factor? 4 is the common highest factor, so 4 will be the result. Okay, same thing if you are calculating the common factor, highest common factor between 6 and 12, obviously 6 only. So here 1, 3, 6, and here 1, yeah, here 3 will also come now. 1, 3, 1, 2, here 2 will also come. 1, 2, 3, 6, 1, 2, 3, 4, 6, then 12. So here highest common one is 6. That is how we will identify. Okay, but logically when we write the program logic, it will go somewhat different. Okay, because we need to check whether it is a factor to the given number or not. First we need to check, and based on that logic only we need to print the highest common factor. Here you can see how we are doing it. Yeah, we are reading, because common factor we are finding, so we are reading two numbers here, and this approach, it is the iterative approach, iterative solution for finding the greatest common divisor, that is GCD. Simple code, we are reading two numbers n1 n2, we are reading a loop control variable I, and whatever greatest common divisor we will get now, we'll put into GCD. Okay, we'll put into GCD. And what we are doing, after we are reading n1 n2, say suppose n value we are reading, n1 value we are reading 4, and n2 value we are reading 12. Okay, n1 4, n2 12. Then what I'm doing, I'm simply taking one loop, I value I'm initializing to 1. Okay, then I'm checking whether I value, is it less than n1, that is less than 4, yes, less than 12, yes. Then what I'm doing now, I plus plus I'm doing. Sorry, after checking condition, the control enters into the loop, and here I'm checking one particular condition, whether I is, I mean, one I value is perfectly dividing n1 as well as n2 or not. I value is what? I value is 1. Okay, I value is 1. So 1 will divide 4 perfectly as well as 12 perfectly. So both these will become true. So your GCD will become what? I value. GCD will become your I value. So GCD is 1. Okay, GCD is 1 now. Next, it will go to the next iteration. I value gets updated. I value will become 2 now. This thing, in this iteration, again I will check whether I value, that is 2, will divide both these numbers perfectly or not. Perfectly dividing in the sense the remainder should be 0. We know that one. Okay, 2 perfectly divides 4, isn't it? 2 perfectly divides 4 as well as 2 perfectly divides 12. So GCD will become 2 now, because we are assigning that I to 2. If that condition, these two conditions are true, we are assigning I value to GCD. I value is 2 now, and the 2 we are assigning to GCD. So GCD will become 2 now. Next iteration, I value gets updated. I value becomes 3. Okay, I value becomes 3. So now again, condition will be checked. 3 less than or equals to 4, condition true. 3 less than or equals to 12, condition true. Control enters, and 4 modulo division 3, we know that remainder 1 we will get. It is not perfectly divisible. So simply it will be skipped, because we kept and percent, we kept logical and in between. So both the conditions needs to be true in order to assign I value to GCD. But here in this case, 3 will not divide 4 perfectly. Okay, we will get remainder 1. So this particular condition goes false, and I value 3 will not be assigned to GCD. GCD will remain 2 only. In the next iteration, I value gets updated. I value becomes 4 now. I value becomes 4 now. And then once again, 4 less than or equals to 4, condition true. 4 less than or equals to 12, condition true. Now again, we check 4 whether it is perfectly dividing n1, that is 4 or not. 4 perfectly dividing 4. This condition true, and 4 perfectly dividing 12 also. N2 value entamma 12. So 4 perfectly dividing 12 also. So both these conditions are true. So I value 4 will be assigned to GCD. So my GCD will become 4 now. Okay. Again, next iteration, I value gets updated. I value becomes 5. 5 less than or equals to 4. Condition true. 5 less than or equals to 4. Condition true. So the control breaks over here. Loop breaks over here. The control comes out of the loop and it will print the GCD of what is the first N1. N1 enta 4. GCD of 4 and N2 enta 12. Is what is GCD we got? We got GCD as 4. So 4 and 12 GCD 4 అని print అవుతుంది. Hopefully you understood ma. This is your recursive approach. So in the this is your iterative approach. In the recursive approach, the concept is very simple. Again, here you can see we are calling the function by passing n2, recursively calling the function by passing n2 and n1 modulo division n2. ఏదైతే రిమైండర్ వస్తుందో ఆ రిమైండర్ ని పాస్ చేసి once again we are calling the same function ma. So this is how you can easily trace it ma, the way how I'm giving you the solution, right? The tracing solution. In the same way you can trace it. Take n1, n2, okay, read any random value, say 4 and 12 initially. Then here I am calling that function GCD of n1, n2. Here I am calling that function. So n1 4 will be passed and will be stored in this formal n1, and n2 12 will be passed and stored in this formal n2. So n1 4, n2 12. Then I am checking whether n2, our concern is n2 only ma, n2 not equals to 0 or not. Yes, we know that n2 not equals to 0. So then what it is doing? It is calling GCD recursively, because from the GCD we are calling GCD. So it is calling GCD recursively, and GCD of n2 we are passing over here. So n2 pass చేస్తున్నామంటే ఇక్కడ ఎంత పాస్ అవుతుందమ్మా? 12 ఇక్కడ పాస్ అవుతుంది, and n1 modulo division n2 we are passing here. Okay, n1 modulo division n2 we are passing here. So how much it will be? 4 modulo division 12. Isn't it? N1 modulo division n2 in the sense 4 modulo division 12. So here 0 will be passed. Okay, 0 will be passed. So what happens now? So after this, okay, after this we got n2 value as 12 and sorry, not n2, n1 value as 12, because this parameter location is what ma? N1 location. So from here to here it will go, isn't it? From here to here it will go. So your n1 will become 12 now. Okay, your n1 will become 12 now. I mean, quite confusing. N1 will become 12 now, and n2 will become what? 0 ma. Here n1 value, previously it was 4 modulo division 12. So how? Sorry, 4 modulo, sorry, here this is not 0. See, if you divide 4 with 12, what reminder you will get ma? 12 0 0, reminder 4 only you will get. So 4 will be passed here. Okay, 4 will be passed here. So your n2 will become 4. N2 will become 4. This is the first call, and this is the recursive call. After recursive call, your n1 value is 12, n2 value is 4. Okay, next how it will be? Okay, next again n2 will be compared with 0. N2 what we got ma? Now here we got 12, here we got 4. Okay, here we got 4, just values get swapped. Okay, then n2 not equals to 0, correct only. Then again we are calling recursively by passing n2 value here, n2 value here we are passing. So how much it is? N2 value 4 we are passing here, and here we are calculating n1 modulo division n2. How much it will be? N1 is how much? 12 modulo division 4. So what we will get, my reminder? 0 we will get, isn't it? So 4 threes, 12 we are passing, so 0 we will get. So here 0 will be passed. Okay, so in the next iteration, in the next recursion, n1 will become what? N1 will become 4 and n2 will become 0. N1 will become 4, and because in place of n1 we pass the n2, so n1 will become 4 and n2 will become 0. Okay, hope you understood. So in the next iteration call, again n1 becoming 4 and n2 becoming 0. So with this, here n2 will be compared with 0. So 0 not equals to 0. This if condition is false, so control goes to the else part. And what we are returning? Returning n1 ma. So what we have inside n1? 4 we have, as you can see. So that 4, simply 4 will come over here, and that 4 will be replaced with this what we call here. Here 4 will come and 4 will be replaced with this entire call. So you will get n1 how much? These are actual parameters. N1 we have 4, n2 we have 12, and this after recursive calls, this GCD of n1 n2 we got replaced with 4. So we see GCD of 12 and 4 is 4. Okay, so yeah, basically in n1 I read 12 and in n2 I read 4 over here, but in our example, I mean whatever I practiced over there, I said 12 as n1, 4 as n2. So similarly I am getting 12 and 4 GCD 4 I am getting. Okay, but in our case we took 4 here, 12 here, and GCD 4 here we got. Hopefully it is clear. Okay, in this way you can trace how many times it is calling recursively, that many times just take the recursive call, and finally ultimately you will get the solution. Hopefully it is clear for you. Okay, so then we see the advantages of recursion. So the code will become easier to write because less code we have to write, and problems, there are certain problems through recursion only we can solve such problems, like towers of Hanoi. This towers of Hanoi to solve, we need to depend on recursion only. Okay, and this recursion will reduce the unnecessary function calling. Okay, and it is extremely useful in if the same solution is applied again and again. So the way how we calculated factorial, Fibonacci and recursion, GCD, in every solution, in every example, the same type of solution is repeatedly applied. So over there you can replace such a thing with recursion. Okay, and recursion will reduce the length of code. Number of lines ఏవైతే ఉంటాయో మన ప్రోగ్రామ్ లో ఆ number of lines reduce అయిపోతాయమ్మా. Then it is very useful in solving data structure problems. When you go for data structures like stacks evaluation, infix, postfix, prefix evaluation, there you will understand. Okay, to do infix, prefix, postfix, the only solution is recursive call ma. Iteration lo manam rayalemu code ni. Using iteration we can't write the code in stack evaluations, infix, postfix, prefix evaluation. Okay, what are these and how you do it, you will understand in data structures. Okay, just remember this 5-6 points as advantages of recursion. Same time we have some disadvantages, some limitations of recursion. Code short అయిపోతుంది కానీ code understanding will become confusing. Okay, that is one of the major problem of recursion, we can say. Even though the code will become reduced, okay, less number of lines we will write, but understanding, analyzing the code, understanding the code will become very difficult, very hard. Okay, third point you can see here, the point which I am saying I wrote here, third point, hard to analyze or understand the code. Okay, recursive functions are generally slower they are slower when compared with non-recursive functions. Okay, it may require a lot of memory space if you go into recursive calls. Every time when we jump from one function call to another function call, we need to store the entire local space into a stack. Okay, it is an overhead on the machine. Recursive call, it is an overhead on the machine, but it is more efficient. How it is more efficient, in the sense, in terms of space and time complexity analysis. What is space complexity, what is time complexity, you will understand very soon. So in terms of space and time complexity analysis, the recursive approach is more efficient. Okay, so if we don't control the recursive calls properly, here you can see recursive calls are not properly checked or not properly controlled, what will happen, we will run out of the memory. Okay, at some point the computer will run out of the memory. Okay, so these are some of the limitations or some of the drawbacks which we need to discuss under recursion. Okay, so hopefully you are clear with this concept. Recursion, a function calling itself, is nothing but recursion. Okay, so with this understanding, I'm concluding today's session. And ఈ త్రీ ఎగ్జాంపుల్స్ కంపల్సరీగా మనం ప్రాక్టీస్ చేయాలమ్మా. You are finding factorial in both approaches, iterative approach as well as recursive approach. Finding the Fibonacci series, printing the Fibonacci series up to given number, this also you need to practice both in iterative definition as well as recursive definition. And finally, finding the GCD also you need to practice both in iterative definition as well as recursive definition. Okay, with this understanding, I'm concluding today's session. Thank you, students.